Hey, people who are gone. We are on the, I don't know, the back side of the cookie sheet, which is 6-1 stuff. I gave you this on Friday or Friday, something like that. I told you guys on Friday to do 8, 9, 10. We're going to check those over and see how you did. And then we're going to do 11 through 15 together. We will then bump back to the notes and go over some things, and then I'll have you guys do this for homework, and then also probably a few problems on the new sheet that I'm giving you that looks like this. Okay, so lots of stuff to do today. Here we go. 8, 9, 10. How many standard deviations above the mean is a 97? So we filled out this bell curve the other day. 97 is about, I don't know, like here-ish, right? So it's got to be a z-score between 2 and 3, right? How many standard deviations? It's between 2 and 3. If you calculate that exactly, it's like x minus x bar divided by the standard deviation. Get that formula stuck in your head. Okay? What is x? Your value, 97. The average we said was 89. And we divide that by 3. And you should have gotten 2.67, 2 and 2/3, 2.67, something like that. Okay, so 8 and 9 were kind of a trick question because it says how many standard deviations are you above the mean? You are 2.67 standard deviations above the mean. What is the z-score for 97 then? 2.67. Those are saying exactly the same thing. Z-score is the number of standard deviations that you are. Okay, now we have to use that laminated sheet. You'll need that as well. Gosh, you got lots of papers that you need. Lots of papers. To figure out how many students are what percentage. When they ask for percent, they're asking you to look it up in the chart. Okay? If it is an exact nice, like standard deviation, like 3 or 2 or -3, you can use this thing and just do the percentage there. But if it's a decimal, you have to use this laminated sheet. Okay? So we're going to go to the positive side because 2.67 is positive. What? Lily needs one of those. Lily needs one of those. Do you need one? Also, I can give you one for now. All right. So positive side, 2.67. If you look it up, what do you get? Anybody know? What? Blurry. I know it's hard to see. What? 0.9962. Okay. So that is 99.62%. Okay, so let's check that out and see if that makes sense. Okay, we are saying how many people are below a 97. If 97 lives here, below, does that represent probably about 99.62%? I would say, right? So there's that. All right, now we didn't move on from there. Some of you maybe have done 11. What percent scored above a 97? 100 minus that, so 0.38%, like less than 1%. You just take this guy and you subtract from 100, okay? All right, now they're going to move on to a different one. What is the z-score of 85? How do you find that? 85 is our x minus the average, which is 89, and divide by the standard deviation, which is 3, okay? So 85 minus 89 divided by 3, that gives me a z of something like -4/3, so -1.33. Check me and make sure that's right. This is my z-score, right? Okay, that tells me that I am a little bit over 1 standard deviation below the mean, right? Do we all understand that? Okay. What percent of students scored below an 85? How do you find it? Trying to find it on the chart. 89 is the average. 85 would be here. Okay, so I always like look at it on a bell curve. We're trying to find how many's below that. What do I know that number is going to be? Less than half, less than 50%, right? Looking at the bell curve, right? Less than half. If you look up -1.33 on your negative side, -1.33, what do you get? I know it's hard to see. I might have to reprint these and relaminate. I don't know. We'll see. 918. 0.0918. What does that mean? 9.18%. So there's about 9% of people scored below an 85 on the test if the average was an 89, right? Okay, now this is the tricky part. This is the really tricky part. what percent of students, so really focus on this one, what percent of students scored between an 84 and a 91, okay? I really, really strongly suggest for you to like draw the bell curve and write where these numbers are located because it will help you a lot, okay? Always put your your average in the middle, or your mean in the middle is 89. We are wanting to know between an 84, which is over here, and a 91, which is here. I want to know, like, if I shade this in, what percentage is that? That's what I'm trying to find, okay? All right, are you paying attention? Are you focused? Okay, this is the hard part. Maybe, I don't know, maybe you think it's still pretty easy, okay? We want to find a z-score for each one. So I'm going to go z of 84, and I'm going to go z of 91. I'm going to try to find those guys as z's. And since I'm doing two of them, I use like that subscript to know which one I'm doing, okay? So z84, z91, we do 84 minus what? 89, because that's still the average, divided by 3. The other one I would do just 91 minus 89 divided by 3, okay? All right, 84 minus 89, that's 5. 5 divided by 3 is negative 1.67. Check me. Okay. All right, so that's that z-score. All right. The 91 minus 89, that is 2/3, so positive 0.67. Yes? Good? Okay. All right. So I'm going to write those on my bell curve over here. I have this guy is at a negative 1.67, and I have this guy is at a positive 0.67. Okay, are we feeling good about this? We're okay for now? Okay, let's just pick one of them. Let's do the left one first. Negative 1.67. If we look that up on the chart, negative 1.67, negative 1.67 is 0.0475. Okay, 0.0475, because these charts always read to the left. That means that there's about 4, almost 5% that's below that, right? Okay. Now, if I read the other one, positive 0.67, make sure on the positive side, positive side, positive side. 7486, that's from here back. So 0.7486, okay? So about 75% are below the right one, about 4% below the other one. How do I find how much is in the middle? You just subtract them, right? So 0.74, hold on just a second, I'm slow. 0.0475, if you subtract those two, you get what? 0.7011. 0.7011, or 70.11% will be the percentage that's in between those two. Does that make sense? That wasn't terribly difficult. It's just doing two of them and subtracting, okay? But it really, really, really helps for you to draw this guy. I have to draw it still, and I've been teaching this for like 10 years now, okay? So I still have to draw it. It helps significantly. Okay, good? Okay, now, this next question is kind of branching off of that. If there are 20 students in class, that's like saying n is 20. If there are 20 students in the class, how many of those students scored between an 84 and a 91? Right? Kind of using the same numbers as what we did in the first question and the question above. Yeah, we know that 70% scored between an 84 and a 91. Okay, so we're going to multiply that by 20, and that's going to tell me exactly how many of those students were. What's 70% of 20? 14 point something, whatever. 0.02, but we can't have 0.02 of a student, so we're just going to say approximately 14 students. Does that make sense? They're asking specifically for how many students that is. Yeah? Specifically, how many students is that? Good? Good, good? Okay, let's bump back over to, it's Wednesday in here that we have shortened periods, right? Okay, all right, okay. What? Oh, I didn't get through 6-1. Here we go. Bump back over to the notes real fast. Let's see what we have done and what we have not done yet. We're on example 5, I think. Okay, I'm going to skip through some of this stuff. We'll do some of the good examples, but we'll skip over some of the other ones that we already know how to do. Example 5 is a good one. Okay, example 5. We're still talking about bone density tests, and we have a reading between a -1 and a -2.5. indicates the subject has osteopenia, which is the prerequisite basically for osteoporosis, which is some bone loss. Find the probability that a randomly selected subject has a reading between -1 and a -2.5. Okay, so I have to draw the picture out. 0 lives here. Okay, -1 lives here. -2.5 lives here. Okay. Now, we just did an example exactly like this, except we had to convert to the z-score. They're already giving us the z-score here, right? All we have to do is look up on the chart and figure that stuff out. So I'm trying to find what percentage is here, okay? Let's do some guesstimating. What do we know about this percentage, probably?
Less than half.
It's going to be less than half, right? 50% would be from here, this direction, right? We're doing just a little chunk of that, right? So it's going to be less than 50%, okay? We're going to be on the negative chart, so let's figure out this. Let's do -1 first. From -1 on back, looking at your chart, 0.1587. Okay. From -2.5 on back, like positive 0.0 something. 0062. Like not very much, right? Like less than 1% is going to be below that, right? Okay. To find the middle of those, or what percentage is in between those, subtract 0.1525. So that means what? 15.25% have a bone density between a -1 and a -2.5. Is this making sense? Are we doing okay? Okay. So when they give you like the between, you're just going to find each one of the values and subtract. But I like to write it out on a chart so that you can see it. It makes it lots easier, right? Lots easier. Okay, good? Okay, so you're doing between two regions, that type of thing, blah, blah, blah. Okay, let's go to this one. This one's a really, really good one. Example 6, bone density test, finding a test score. Okay, use the same bone density test scores used in earlier examples. Those scores are normally distributed with a mean of 0 and a standard deviation of 1 so that they meet the requirements, blah, blah, blah. Here we go. Draw your bell curve. Here's where 0 lives. Okay, find the bone density score that corresponds to the 95th percentile. Okay, if you are in the 95th percentile, what's that mean?
You're above everybody.
95% is below you. Does that make sense? Okay, only 5% of people are above you. 90 percentiles say how many's below. Okay, so where are we living on this bell curve? Like all the way on the right side. We're over here. This is the 95th percentile. Okay, I'm going to say 95th percentile. Right here. That means 95% is below you. 95%. Okay, we're trying to figure out what your z-score is. Right? What is your z-score? Okay, so this is kind of tricky. Normally they give me this and they have me find this. Now they're giving it to me backwards, right? So we have to kind of look it up in the table backwards. Okay, they give all these numbers in the table as 4 decimal places. What's 95% is 4 decimal places? 0.9500. So what we're going to do is in this chart, are we going to be on the positive or the negative? Positive side, because we're on the right, right? We're looking at these numbers in here. You're not going to probably find 95 exactly, but you're going to find whichever one's closest to it. 1.65. 1.65. I believe you. I just have to find it. Wait a second. I'm in the negative side. Blah, 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 blah. 1.65. Okay, you see the star in between 4 and 5? Mm-hmm. I think that is all like exactly in between. So go down and over. 1.645. That's one of the only times where those stars are. That's one of the only times that you'll go 3 decimal places. Do you see where they have that star in the middle? Okay, you're finding these guys in here. So you're trying to find 0.9500 inside here. There's a star right here in the middle that has, and if you go down, it's 1.645. Okay? So what's that mean? 1.645. So if I'm in the 95th percentile, meaning that I have like better bones than 95% of people, my z-score is 1.645. Does that make sense? Yeah. Yeah, so we can look it up backwards. It depends on what you're given. If you're given z-score, you're going to look it up forwards. If you're given percentile, you're going to look it up backwards. Right? You're looking up these numbers in the table and finding the closest one. Are we confused? No confusion? Okay. Okay, let's go to reading the backwards is what got you? Are you okay? Okay, you got it? Okay. All right. Let's go. Let's do example 7. We'll skip example 8. Here we go. Last one. Example 7. Here we go. Okay, using the same bone density test described in example 3, we have a standard normal distribution with a mean of 0, standard deviation of 1. Find the bone density test score that separates the bottom 2.5% from the top 2.5%. So we're finding two numbers, right? We're finding like this bottom 2.5%, like over here, and the top 2.5%. Tricky, tricky, tricky. We want to find the z-score, so we're looking at backwards again. But we got to figure out what we're looking at, right? We got to find those z-scores. Okay, so if we're trying to find the left one, like let's start with this guy here. What number are you going to look up? What? 2.5%? What is 2.5% as a decimal? 0.0. I think it's just 10. 0.0250. Is that 2.5%? You're looking at 0.0250, yeah?
Yeah.
In the which side? Negative side, okay? You're looking it up backwards. So go to the negative side and you find the one that's closest to 0.0250. Does this one have a star also? No, it doesn't.
Oh, yes, but not for those.
Yeah. 0.0250. I think I find him exactly. Yeah, that's right. Did you find him?
Nope.
Nope. I know, it's so hard to see.
I found it.
I found it. Me too. Okay.
Did you find it?
Yep.
What'd you find?
Negative 1.96.
Negative 1.96. Okay?
Yeah.
So if you have a z-score of negative 1.96, you're like real low. Like in the 2.5 percentile. Like if this was height, that would be my child. Like that's literally, like she's in the 2.5 percentile. Anyway. All right, so there's that, okay? Now we want to find the z-score for the top one, top 2.5%. So here's the tricky part. They are saying 2.5% are above you, but the table only reads to the left. So what percentage would you be looking up if you're looking at everything to the left?
97.5.
97.5%, or 0.0975. No, 0.9750. I'm just trying to see if you're paying attention. That's a lie. That's a lie. 0.9750 is what you're looking at, yeah? Right? Do you see why it's 97.5% and not 2.5%? On the positive table, what do you get?
1.96.
Oh man, you mean to tell me that they are at the same spot on either side? Now don't you feel like hitting yourself in the head? Like really? Did we have to look that up because it's the same spot on the other side? Okay, so now you know that if you're looking at the same place on either side, it's going to be the same z-score, right? And you can just like cheat and only look up one of them, right? Yeah, as long as you do it right. Like it'd be really bad to be wrong twice. But anyway, so there's that, right? Make sense? Good? Okay, go to the cookie sheet. Go to the cookie sheet. Go to the cookie sheet, the back side of the cookie sheet. The back side of the cookie sheet. Let's do, fill this bell curve out together, and let's do like one more of these because I want to show you something else that we didn't do in the notes, and then I'll just let you work. How about that? Okay, good? All right, the number of chocolate chips in a bag of chocolate chip cookies is approximately normally distributed with a mean of, I want to know who counted these. Anyway, the mean X bar is 1263, and the standard deviation, I'm going to write off to the side, is 117. 1263, 117. Here we go. 1263 goes right there, really tiny. Okay, now we're going to add and subtract and add and subtract and add and subtract. Whoop. I don't know. I can maybe add 1, nope, 0, 8, 3. 1380. Somebody check me. 1380. 1497. And 1614. Thank you. Whoop. Okay. If we subtract 1263 minus 117, I can't do that. Somebody got to give it to me. 1156, 46, 1146. Okay. 1029 and 912. Okay, there they are.
What was the last number?
What?
What was the last number?
912. Yep. Okay. Also on here, do this. Zeros here. And then 1, and then 2, and then 3. And then -1, and then -2, and then -3. And those are the what? What are those numbers? Those are the z-score. That's the number of... No, you're right. You're both right, because they're both the same thing. That's the number of standard deviations that you are. That's the z-score, right? Okay? So, like on number 1, when they ask you approximately what % of bags contain more than 1380. Do we have 1380 on our chart exactly? Yeah. So, they're saying more than that. So, you can look up 1 exactly on the positive chart, or you can look up these percentages. They're going to be exactly the same or pretty close to the same. If you look up 1 here, this would be like 13.5%, 2.4%, and 0.1% or something like that. If you look up the empirical chart, that bell curvy chart, you know what I'm talking about? Okay? Because he comes out to be exactly 1380, we have exactly on our chart, you can use this guy. Okay? So what % of people are more than 1380? 16 exactly. 16%. Okay? All right. You can do the rest of those except skip down to like number, I don't know, 9. Number 9. What? No. We're going to skip down to number 9. We're going to do number 9 together. We're going to do number 9 together. You're going to do the rest of them. We're going to do number 9 together. Okay? Ready? Because number 9 is just one more little tricky thing that we haven't already done. The 95th percentile. Okay? I have to draw my little thing here. I have to draw it. 95th percentile. We want to know how many chocolate chips are in the 95th percentile. Okay? Zero's here. What does 95th percentile mean?
95% below.
Okay, so where do we live?
Right there.
Right there. Right? Ish, something like that. That means 95% are below us, right? If it's a 95th percentile, 95 are below us, okay? So as a decimal, 95th percentile is what? 0.9500. Didn't we look this one up already? If we look it up, we got what? 1.645. Okay, so that is the what? The z-score is 1.645. But I want to know how many chocolate chips that translates into, right? 1.645 is going to be like here on the chart. So maybe like, I don't know, 1,400 chocolate chips, 1,420 chocolate chips, something like that. Well, how do I figure out what that translates into? Yeah. She's doing it in her head. I use the formula. Okay, so z is equal to x minus x bar divided by the standard deviation, right? Okay. So in this case, we know this z. We know that the z is 1.645, right? We know that the standard deviation is 117. What else do we know? The mean or the average is, what is it, 1263? Okay, what are we trying to find? The number. We're trying to find x. So if I have this going on, how do I find what x is? Okay, we got to get x by itself. So we're going to multiply the 117 over. That gets rid of him first. Okay, so take 1.645 times 117. And that is something. 19, what, wait? 192.5? Okay, and that's equal to x minus 1263, right? Some of you guys just do this without actually writing all your steps down. We add the 1263 now to the other side. 1455.5 equals x. That's how many chocolate chips there are. You could probably round that off to 1456 because you can have you can kind of have 0.5 of a chocolate chip, but anyway. So, does that make sense? So that one's just even one more step further after you find z-score. You have to put it back into the formula. So like Ellie was trying to like explain to me, like you find the percentage and then you do, that's probably what you were doing just in your head, right? Yeah. So I like to write the formula out because it makes more sense to me to multiply and then add whatever. So there's how that works. Does that make sense? Are we doing okay? Yep. Okay, so here's what I want you to do. Do the rest of that cookie sheet for tomorrow. And then I might just because there's so many of us gone today and I want to make sure we're all on the same page, I might just give you time tomorrow. We'll just do a work day of this bell curvy thing. Yeah? And we'll do that. If you want to start on it, that's less work for you tomorrow, but do the cookie sheet first. Get those kinks worked out, and then we'll work on the other sheet tomorrow. Okay? Good? Happy with that? All right.
I'm so happy.
Goodbye, people on the video.